Okay, all right. Well, hello, and this says week 2 Wednesday. It should say week 2 Friday. Sorry for the mistake there. Week 2 Friday. We're looking at function writing strategies. Okay. Now I know already you had to write functions for this first homework assignment, and so it's and some of you came to office hours and said, I don't know if I've written functions before, which surprised me a little bit, but hopefully you were able to figure it out. Looking at some of the resources I've provided. So the textbook, Introduction to Scientific Programming and Simulation Using R. That one's a little bit more gentle, and so if you need to kind of review any kind of concepts, follow the link, download the textbook. Also, Advanced R goes, into real good detail about how all of this stuff works. So you can check that out as well. Or we'll talk about function basics, just because we got to start somewhere. Although this is all going to be kind of review for you, and eventually I just wanted to kind of get into how do we think about more complicated functions. So in homework 2, I don't know if any of you have taken a look already, but a lot of you are still working on homework 1. But for homework 2, you're going to be simulating a game of Chutes and Ladders. It's a board game. You have to write a couple functions on how to draw the game board and things like that. And it's fairly it's not extremely difficult, but it is, it's not a simple thing. It's a little bit more complex. And you have to kind of think about it, and you have to break down the task into smaller chunks. And so I wanted to talk a little bit about some of the strategies to use as far as writing functions. But anyway, when we talk about functions, this is how we do it in R, right? Every language has a way to define functions, and this is R's way of defining a function. And the way you do it is you use the keyword function, and you're going to store that function. So you need a name. What are you going to call your function? And then you say, okay, store into that name, and then you put in function. You put in stuff here, arguments that are going to, these are values that go into the function. The function does stuff with them, so you have expressions, the calculations, stuff that it does. And then the very last line of the function is that it's going to return some kind of value or some kind of object, right? Some kind of output. And here I'm using the keyword return, but it's also you can also leave that out. It's going to reach the end and it will return that. Okay. And so I wrote argument 1 and argument 2 are the names of variables supplied to the function, and the expressions are things that the function does, the code that it's running. Okay, and that could include loops or whatever it might be. And when you call it, you'll call it with name, parentheses, and the values that go in. Okay. If the function has only one line, the curly braces can be left off, and so this function of x will return x times x, and that will be that. Although it's generally good practice to use the curly braces. It's generally good practice to format your functions nicely. Okay. You can put functions. It's an object just like any other object in R, and so you can put them inside of the list. Oddly enough, when you ask what is the type of for a function, the word that R uses is a closure. But if you ask what's the mode, it's a function. It's a little bit weird. I'm not sure why R has different names for these things, but that's just what it appears. Okay. Functions frequently return values. Okay, and what return just does is that when you run the function, and let's say you wanted to store the results of the function somewhere, right? What is the thing that's going to it store? That's whatever is returned, right? So when you run, the function that you wrote in the homework, the by type function, what is being returned is a list, right? At least that's what it's supposed to do, right? It's supposed to be a list of 3 things. That's the thing that's being returned, okay? Now you can use this keyword return and that will explicitly return a thing. And if, as the function's running, if it encounters the word return, it ends, okay? It's not gonna run anything after it encounters the word return. So for example, if you have a function and somewhere in there you have if this and this, then return this, then it's gonna stop. It's gonna return that value. The purpose of the function has been fulfilled, and it's not going to run anything after that, okay? So it runs the code, and then as soon as it counters return, it says, my work here is done, and anything after return, it's not gonna do. The implicit is that the function runs, and whatever is the very last line of code, that's the thing that's gonna be returned, okay? So if the very last line of code is a single object name, then it returns that object, okay? If the last line of code is something like x times x, it's going to return the value of x times x. And most style guidelines will recommend this, the implicit, just going to the very, very end. At least our style guidelines. Now that's very different from many other style guidelines, and say in Python or something, you have to use return and stuff, or not have to, but that's that. Okay, functions are only able to return one object. If you want to return more than one value, right? If you want more than one value, they have to be kind of grouped together into a single object. So you either have to group them together into a single vector if they're of the same type. If they're of different types, you have to group them together with a list. And so, a function that you're probably familiar with, even though we haven't used it in this class, is the linear model function, LM. So if you're taking 101A, and you're doing a regression model, you use LM, and the results of LM are actually this big list. It's an LM, it's a list, and it's got things like the coefficients and the residuals, and I don't know. There's a whole bunch of stuff in that list, and it's all these different things, and they're all grouped together. So here I've got a simple function. It's going to group together the values x squared, and x cubed, and it groups them together into a single vector, and that's what we have. Here I've got the values being grouped together into a single list, and that's what's being returned. With functions, you take in the values with different argument names. And so, when you define that function and you're going to say, okay, these are the different arguments that we're going to accept, you are defining the names of the arguments in that moment. As soon as you define this function and you say f is going to be a function of x, y, and z, you have now given names to these three things, right? Because you're putting three values in. Now those three values get referred to by the names x, y, and z, right? So whatever you put in here, those are the names you're going to be using. And when you call the function in R, if you don't specify the names, then R matches them up in the order, right? So I didn't say x equals 1, y equals 2, and z equals 3, but it's going to match up 1 with the first argument, which is x, 2 with the second argument, which is y, and 3 with the third argument, which is z. Now, this function does the most boring thing, and it just pastes together into a single string. So paste 0 just says, take these different things, first make everything a string, and then it just kind of glues them together, okay? Concatenates them together. So it's pasting together x space equals space, and then whatever value comes in for x, a 1, paste it together with the character comma space, y space equals space, and then the value of y, paste it together with the characters comma 0, z space equals space, and then the value for z. And then so this is a single character string, x equals 1, y equals 2, z equals 3. Okay, but this allows you to see where x, y, and z end up being. Okay, paste 0 is, there's two functions, paste and paste 0. The paste function will automatically insert a space between arguments, and then paste 0 automatically inserts no space between arguments. So that's the difference there. All right, so when you call the function, you can specify the arguments, and I could say z equals 1, x equals 2, and y equals 3, and then it's going to go through the function and then just kind of match up and says, oh, x equals 2, so that's going to go into position x, and so on and so forth, and then we get this thing that basically says exactly what we're going to do. Okay. So here, R will do its best to try to match things up. So here I said run the function y equals 2, and then I also provide the arguments 1 and 3. So in that case, R says y equals 2, and then it figures out, okay, this is going to go into position x, and then this will go into the other leftover argument 3. And here I've got y equals 2. I left a blank 1 here, and x equals 3, and R matches this up, right? This would throw an error in something like Python, but in R kind of matches it up and is able to function, okay? If you give it an argument that it doesn't know what to use, so I give it 1, 2, 3, and m equals 1, R throws an error and says, hey, you've given me an argument, m equals 1, and I have nowhere to put this, so something is wrong, right? Something is wrong. The way you've called this function just isn't going to work. Unused argument, m equals 1, right? And that was, you might have encountered something similar when you called print and you gave it a whole bunch of things and it couldn't figure out how to use some of the arguments that you used, right? You have to provide arguments, values, if it's going to use it. So notice here I'm defining a function with 4 arguments, but you'll notice the code doesn't use argument w, okay? It doesn't use argument w, and so R doesn't actually care. So I can do f is a function of 1, 2, 3, 4, and it uses x, y, z, 1, 2, 3, and it doesn't use that value 4, and R is like, okay, whatever. Okay, you gave me an argument, w equals 4. I didn't end up using that, but that's fine, okay? Here I have function, and I call 1 of 1, 2, 3, and x is 1, y is 2, z is 3, and w isn't provided, and R doesn't care. Okay. Here I have x, y, z, w. Again, same thing, only x, y, and z are used. And here I say x is 1, y is 2, and w is 4. Z is not provided, but z is utilized in the code. And if you do that, you get an error, right? And it says error in this line of code, argument z is missing. And it's saying, hey, I need a z here, and I don't have a value. So it throws an error, right? So, one of the skills that I want you to develop in this class, and again, this is something that gets developed as you do your homework, is being able to read error messages, okay? So in the beginning, it feels like you encounter an error and you go, oh, I don't know what to do, right? Help me, right? But there's actually a lot of information being provided in the error messages when you encounter them, right? So as you do your homework and you encounter errors, and you will, all right? Nobody is able to write code 100% correct right from the beginning, okay? So you will encounter error messages, and as you continue coding throughout your career, you will continue to encounter error messages. But the key difference between someone who's starting and somebody who is experienced is what they are able to do with those error messages. So you read that error message and you try to think. Don't just give up when you encounter an error message, right? Try to think through and say, hey, what is this error message telling me? Can I figure out where to identify, right? And so one nice thing about R is it tells you exactly what line of code is throwing the error message, okay? And that line of code could be inside of a function being called somewhere else, right? So, you write something and it says like, here's an error message, and you're like, I don't even see this thing, but you have to kind of think, one thing you can do is you can like highlight and copy and search for this particular thing and find out, okay, this is where this line is appearing, right? And then try to make sense of whatever this message is saying, right? Argument z is missing. Okay, it says, well, I don't have a z, right? Or missing value when true false needed, right? That's encountering an if and stuff. So take the error messages as like clues, okay, and not just throw up your hands. So that's an important skill to develop. Okay, so one thing you can do when you define a function is you can provide default arguments, right? And default arguments allows your function to run even if values aren't provided. So here we're going to say this function, the same function we've been using, we have default arguments where x, y, and z, if we don't provide those values, are going to take on 1. And so now I can call the function with no arguments provided, and it will use the defaults. If I provide a function argument 2, it is going to go into the first position, x equals 2, or you can specify z equals 3, and it's going to plug it in where it sees it. One thing to remember is that when you execute code in a function, the values, the variables, all the objects that are created inside that function, they only exist inside the function, and they only exist during the execution of the function. And as soon as the function is done running, those values, those objects, they disappear at the end, okay? And there's no way to use them unless you send them back out, okay? And there are a couple tools you can use. You can use like global assignment and stuff, and we'll cover that later, but it's something you shouldn't be using, okay? So don't, it's like, I'm gonna show you this tool, but it's like, please don't use this tool, okay? And that will come later, but generally, with R, don't try to change values in the global environment from inside the function. If you want to get a value out of the function, it needs to be part of whatever's being returned, okay? All right, let me give you your first view quiz answer, which is the letter B. B as in bear. B is your first view quiz answer, B. All right, so here's just an example illustration of how the stuff inside a function does not interact with stuff outside the function. So I'm defining object X in the global environment. It takes on the value 10. Here's the function f. It takes in some value x, okay? We're gonna add 55 to x and store that back into x, and it's gonna return the value x. So when I call f on x, it takes the value 10 from the global environment, it adds 55, so it saves that as 65, it returns x, all right, and it returns 65, okay? But if we ask, hey, what is the value of x in the global environment? This operation where we said add 55 to x and save it as x only operates inside the function and doesn't touch the x that's inside the global environment, right? So when you run the function, it like creates its own little sandbox. It does stuff over here, doesn't actually affect anything outside in the global environment, okay? So x is 10, f of x gives us 65, x is still 10. If we do want to change what's in the global environment, I have to take this object f of x that it returns 65, and I've got to save it back, right? So now this operation, where I'm going to do f of x and we're going to assign it back into x, this thing will now affect what's happening in the global environment, right? Because we're saying, okay, take whatever f of x returns and assign it to the name x. And now x in the global environment has the value 65. All right, when do we write functions? And the answer is you should write functions frequently. And anytime you find yourself reusing a piece of code and you need to kind of change and adapt values, okay, then you should write a function. And if you find yourself ever copying and pasting a chunk of code and then replacing variable name 1 with variable name 2, okay? Copy and paste one time, I guess, is okay. But if you copy and paste it twice, all right, then you should really start thinking about a function. And then by the third time you say you're gonna have to copy and paste the thing, definitely 100% you should turn this into a function, okay? So this is the thing, right? You should not copy and paste the same chunk of code more than 2 times. That's kind of my guideline. So that's a very common thing, right? You find yourself making a graph and you're like, okay, I like the way this graph looks, and then now I want to do the same thing with a different variable. So you take all the code to write the graph, and then you copy and you paste it, and then you're going to change the variable name to something else, right? And then you say, oh, let's do this again for another thing, and you copy and paste that, and you make the same graph with something else, right? If you find yourself doing that, wrap all of that code into a single function where you're going to have the argument for the variable name, right? And then and then you can execute that graph over and over and over, that one function, and you just change the variable name. Okay, so that's a very common thing. If you find yourself copying and pasting, turn it into a function. Okay, and what that does is, let's say later on you realize, oh, you know what? I want to change the way this graph looks, right? I want to change the line from blue to red everywhere, okay? Or I want to be able to add these tick marks, right? And you say, I want to do this. If you copied and pasted, then you have to go through and you have to like find that edit and make the edit there, and then make the edit somewhere else and make the edit somewhere else. But if you wrote a function, you change it one time, and it's going to now affect every time you call that function. And so that's going to make it a lot more easier to kind of make things consistent, fix errors and things like that, right? So better change the code in one location than try to change copies of the code everywhere. You should name your function in a way that makes it clear what the function does, all right? So throughout these slides, I frequently just name my functions f and f2 and f3 and things like that. Those are terrible names for functions, okay? Those are terrible names for functions. As you are writing functions, you should think of like, okay, what is this function doing? And then and name the function according to that, right? Sometimes you want to write a function where it's going to return a true-false value, okay? And in those cases, you should name your function almost as if it's a yes or no question, right? And then you can say is character or is prime, those return true or false values. And so it's kind of like the function is answering the question, is it prime? And then it's going to return true. Is it prime? It's going to return false, type of thing, right? So those are how you should name your functions. Okay, let's walk through strategies for writing a function, okay? And so there is a sorting algorithm called bubble sort, right? And so I don't know if you've taken like any kind of algorithms class or something, and there's like all kinds of different sorting algorithms and quick sort and all of these things. One of the earlier sorting algorithms was bubble sort, all right? And this bubble sort was an important algorithm when computer memory was limited, okay? So if you think about like, if I give you on a deck of cards, okay, and they're all shuffled, right? Or actually not a deck of cards, but I give you a bunch of cards and they all have different numbers on them, and they're shuffled up, and I say you need to sort them, right? There's a whole bunch of different ways you can do this, but you might like try to lay it out on on a table and then try to sort them and things like that, okay? But in the old days, computers had very limited memory, and being able to, quote, lay out all of the values in memory or something just might not have been a luxury that was afforded. And so bubble sort allowed us to kind of, I say us, but it was just allowed programmers to sort values with very limited memory usage, okay? And the way it works is, starting from the beginning of the list, you compare every adjacent pair. So it's only looking at two values at a time. And if they're in order, leave it. And if they're not in the right order, you swap the positions, okay? And you do this every single time. You go through the entire list that way. And then you iterate over and over and over. And if you keep doing that, eventually the entire list is going to be sorted. So it's a lot of computations, but it doesn't require a lot of memory. All right, so here is how the bubble sort algorithm would work if you have this vector 5, 1, 8, 2, 4. So during the first pass, it compares the two values that are adjacent. 5, 1, they are not in the correct order, so it swaps them, okay? And now we get 1, 5, 8, 2, 4. Then it goes to the next pair, okay? 1, 5, 8, 2, 4, it looks at 5, 8. Those are already in the correct order, so it leaves them. Then it goes to the next thing. 8, 2, it looks at 8, 2. Those are not in the correct order, so it swaps them. And now we get 1, 5, 2, 8, 4. And then it looks at the last pair of values, 8, 4. Those are not in the correct order, so it's going to swap them, right? So it's we call it bubble sort because it's like, here's like a little bubble, okay? And the bubble kind of moves along. And as it's going, the largest value, okay, during the first pass, the largest value, the 8, gets caught and it gets carried up, like kind of like a bubbles rising type of thing, okay? And so, so here the 8 ends up all the way at the end. So after the first pass, the largest value in your list will end up all the way to the right. Okay. Now, now that we've done that, we can kind of lock in the 8. I mean, we don't have to, but we can lock it in, and we do the same thing. Okay, 1, 5, 2, 4. We swap the 1. We leave the 1 and the 5. They are already in the correct order. Then we compare the 5 and the 2. Okay, the 5 and the 2 are in the wrong order, so we swap them. We compare the 5 and the 4. The 5 and the 4 are in the wrong order, so we swap them. And now the 5 has ended up all the way to the right. Okay, and so this. So we know the 5 is already in the correct spot, and we don't have to do the 5 and the 8 because we already know 8's in the correct spot. And we kind of keep going. So now we have 1, 2, 4. There's no swapping needed there. We compare 2 and 4. There's no swapping. So 4 is in the correct position. And then lastly, we do 1 and 2, and those are already in the correct order. So no swap there. Okay. And so once we do that, now we know the values are in the correct order: 1, 2, 4, 5, and 8. And so we have sorted our values. So that's how bubble sort works. There is a little GIF. Does this work? Okay, and we can watch just a couple iterations of this. So it's comparing the two values. When they're in the correct order, it swaps the position. This is painfully slow, but okay, here we go. It's looking at the next two, but it does illustrate what's happening, right? And then so it swaps the 6 and the 1. Now we're looking at the 6 and the 8. Those are in the correct order, so it moves on. 8 and 7 are in the wrong order, so they swap, okay? And then, come on, you can do it. All right, there it goes. It swaps the 8, and then we do the 8 and the 4, and then the 8 will get swapped, right? And then now the 8 gets locked in, all right? And then it continues on here, right? And so it's gonna do 5 and the 3, and so on and so forth. And it's gonna kind of push, and the 5 will go, but then eventually the 7 will get caught somewhere along the way, right? So it gets, and then the 7 will get pushed all the way to the right. So the 5 and 6 in the correct position, 6 and 7 are in correct order, at least for those two. And then we now do 7 and 2, and those get swapped, right? And this continues on and on and on, and we don't have to watch the whole thing. But thank you, Wikipedia person who was this? SW Fung 8. Thank you for creating this animation. Okay, so how would you code this, right? How would you code this, right? And again, why would we ever code this? We wouldn't ever have to in real life because we already have sort and it works great, all right? So, you know, this is just kind of an exercise, right? In order to kind of develop your own skills. But let's think about how do we take this big task and break it down into smaller tasks, right? And the two tasks that we can kind of break it down is, all right, let's compare two adjacent values and we'll swap them if they're not in the correct order, all right? And that can be further broken down into two tasks, which is just compare the two values, and then another is swap values. How do we do that, okay? And then the other part is, okay, so we can compare values and swap them, but now we have to be able to perform multiple sweeps, right? And every kind of sweep, we kind of go through all of the values, and then we're going to kind of go into a spot that's locked, and then we're going to kind of keep sweeping through, and we can think, okay, well, that seems like a good candidate for using a loop, but that's what we'll do. All right, so here is a tip. When you write a function, do not immediately start writing a function. And the reason for that is when you execute a function, all the stuff that happens inside a function only exists inside the function and doesn't exist outside of it. And so if something goes wrong, which, you know, the first time you write a function, it's probably not going to work exactly the way you want, it's really hard to debug it. So instead, just write your code straight in the global environment, okay? Don't wrap it inside a function, right? And that way, as stuff happens, you can see what's happening, okay? You can monitor the values. So don't write a function. Start by just getting a piece of code that works. And if you get that code working, then wrap it inside a function, okay? But don't start writing a function. And maybe that would have been good advice to give you before homework 1, But, homework 1, I think the functions were simple enough where, it was a little bit of a challenge and things like that, but you can get through it. But definitely for homework 2, as these functions get more and more complicated, you're going to not want to start by writing a function. You're going to want to start working in the global environment. And then only after you get it working, wrap it up inside a function. Okay, but let's start off with this thing, and let's just... So again, another important thing is as you try to write your code, right, start with a very simple example and say, if I do this one simple task, what is it supposed to look like afterwards, right? So, with something like your prime factor function, you just say, okay, if I have the number 6 and I say find the prime factors, what should it do? It should return 2 and 3, right? And then you just say, okay, if I have this thing, 25, and I do prime factors, what should it return? 5 and 5, things like that, right? And you test these things out, right? And you say, okay, does it work for this? And does it work for this example? And you kind of run it over and over and over again with a whole bunch of different test cases. And then if it works, then you can say, all right, let's wrap it up in a function, then try out a whole bunch of other test cases. But here we got to start off with this vector, 5, 4, 3, 2, 1. And we're going to say, all right, let's see if we can just swap the first 2 values, okay? And then if we do that, we're going to get 4, 5, 3, 2, 1, okay? We're not going for anything ambitious. We're not trying to get this sorted into 1, 2, 3, 4, 5 right away. We start small, and we go, okay, if we want to swap 5 and 4, what will it look like? It should look like 4, 5, 3, 2, 1. Can we do this, okay? How do we do this with code? Well, let's just try, so if I started writing off a function like this, right, and I say, okay, let's take the vector x, let's just swap the first 2 values. Let's take the value in position 2, put it into position 1. Let's take the value in position 1, put it in position 2, and let's return that vector x. What do we end up getting? When I run it on 5, 4, 3, 2, 1, I get 4, 4, 3, 2, 1. 4, 4, 3, 2, 1. What went wrong? Okay? And it's hard to debug this when you write it inside a function right away, okay? And it's hard to know exactly what went wrong. So instead, I'm going to clear out the environment, right? So this is another thing. As you write your functions and you want to get things working, always clear out that environment, right? So always kind of, in RStudio, always be using this broom to clear out things. Because if you don't, the values inside your environment are going to kind of stick around, and then it might look like it's working, but that's only because the old values from the environment were there before. So always kind of clear it out and make sure. So one thing we can do is we can take this code, right? Don't put it inside a function, and we're going to just run it one piece at a time and just see what does stuff look like, right? So we start off with 5, 4, 3, 2, 1. And then I'm going to say, all right, take the second value, put it into the first position. And then let's look at x, right? And so because x is in the global environment, not inside the function, I can say, okay, what does x look like? Okay, now it's 4, 4, 3, 2, 1. And then I want to take the value in the first position and put it in the second position. And then we see, oh, it's still 4, 4, 3, 2, 1. This is why I'm getting 4, 4, 3, 2, 1, is because when I took the second value and put it into the first position, I overwrote that 5, and now that 5 is gone, right? So the problem here is if I just kind of go straight into saying, okay, take the second value and put it in the first position, it's not going to work. So again, working in the global environment, I delete everything out of the global environment. I'm going to start off with 5, 4, 3, 2, 1. And what we need to do now is we're going to take that first value, that 5, we're going to store it somewhere into temp. Then take the second value, put it into the first position, okay? So that 4 goes into position 1. And then we're going to take that temporary value and put it into the second position. And now I get 4, 5, 3, 2, 1, okay? Now, this was kind of a silly thing, but the idea here is to illustrate that it's a lot easier to troubleshoot what's going on if you're working in the global environment and not inside a function. Because again, inside the function, all of your stuff exists only in that function, then it disappears. So if you're working in the global environment, you can kind of check in on the values and see what they look like as you're working. And so now I have a way to kind of swap values. Okay, and then just to kind of make sure it's still working, okay, just try it with another another example, right? So we're going to just take this chunk of code, all right, the x, and we're going to just try, here's a vector 1, 2, 3, 4, 5, 6, 7, 8. What's it going to look like? The first two values do get swapped, right? 2 and 1. And we go, okay, well, you know what? In this case, I didn't actually want to swap the values, right? If the left is smaller than the right, we want to leave it in the case. So what we're going to do now is we're going to take that chunk of code that we know is working as far as swapping values, but now we're going to put it inside a condition, right? So now we put in a condition that says, okay, only swap the first two values if the first value is greater than the second value. If the first value is greater than the second value, swap them. And if it's not, don't execute the code, okay? So here, again, we're just building up incrementally. I have the vector x is 5, 4, 3, 2, 1. When I run it, what do I want? I do want the values swapped, and I get 4, 5, 3, 2, 1. And then if I try it with 1, 2, 3, 4, 5, and I run that code, no swap is performed. It's still 1, 2, 3, 4, 5, all right? And again, we're not being ambitious at all. We're just, can we swap the first two values? All right, so all we did is we just swapped the first two values. Now what do I need to do? Okay, now I need to move on and say, okay, let's not just swap the first two values, but let's look at the second and third values, then the third and fourth values, fourth and fifth values. How do we do that, right? So now we want to kind of sweep and do comparisons for kind of all the pairs along the way, right? So we have this way to kind of compare adjacent values and swap two adjacent values. And now what we want to do is we want to do this. So instead, I'm just taking the exact same code that I had earlier, and instead of doing position 1 and 2, we're going to replace position 1 with an I and position 2 with I plus 1, right? And I'm going to put it inside a for loop, and I'm going to say for I in sequence length of x, right? So we're going to just put it inside a for loop, and we're going to start off with I is 1, I is 2, I is 3, all the way up to the end, until the end of the thing. And what we're going to do is just any place where I have a 1, I put in an I. Any place where I have a 2, I put in an I plus 1, right? And then so I have x in position I goes into temp, and then do that. And again, this is only going to get executed if x in position I is greater than x in I position I plus 1. Okay? Does that kind of make sense? So again, we're just building up incrementally. And I try running it, okay? And what happened? Okay, so again, I'm running this in the global environment. It's not inside a function, okay? And I run this in the global environment, and I encounter an error. And what happened? It says, error in if xi greater than xi plus 1. So it's in this line of code, we're getting this error. Missing value where true, false needed. So what happened there? So it means either this value xi or xi plus 1 is missing, right? So there's only, right, you look at the line and you said there's only two values in here that are being compared. And so one of these values, or maybe both of those values, are missing, okay? So we look at the, we're working in the global environment, so we can say, okay, well, what is the value of I? I is 5, okay? And what is x of I? X of I is 5. And what is x of I plus 1? That's an NA, okay? And we go, oh, okay, this is where the problem is, right? So by working in the global environment, these are the only variables that you have, xi plus 1, and you have an I, and we can look at all of this, and we can say, oh, okay, this is where our problem is. We're encountering an NA because we're asking for x in position I plus 1, and we went up to position 5, and now we're asking for the 6th position. That doesn't exist. So that makes sense, right? So we don't have an x in the 6th position. So what do? Well, all we do is we just make an adjustment. We say as you're comparing, you don't actually go to the very last value and compare the 5th with the missing 6th value. You stop at the 4th and the 5th values, right? So now all we're going to do is we're going to just make an adjustment to our for loop. And we're going to say for I in sequence length, and how long is our sequence length? It's going to be length x minus 1. Now we're going to stop at position 4, okay? And now we try running this, and lo and behold, when we run it on x is 5, 4, 3, 2, 1, indeed, running through this loop has pushed 5 all the way to the end, okay? And now we have 4, 4, 3, 2, 1, and then 5. So this looks like it's working. And now what we have to do is we just have to run multiple passes of this. Okay. But before we move on, let's just try it again. Okay. Here's 1, 2, 5, 8, 3, 6, and then we will try doing our little bit of code. And indeed, it has pushed the largest value 8 all the way to the end. Right? And so anytime you get something working, just say like, okay, let's try out a couple other test cases, right? And I'm going there. Oh, let me give you your second view quiz answer. Let me go ahead and give you your third view quiz answer too. Second view quiz answer is A as in apple. Third view quiz answer is C as in cat. Okay, second one is A, third one is C. A and C are your second and third view quiz answers, right? All right, so a few more tests. I just randomly sampled 10 values, and then I try out the line of code, and indeed, it's pushing the largest value all the way to the right. Okay, we're still working in the global environment. Okay, so now the last thing I need to do to kind of get this whole thing to work is I want to do this again and again so that every time I run it, one more position is locked. Okay, so here I've just run the same exact code, okay? And if I run this, I have 5, 4, 3, 2, 1, and I run it, I get, it pushes the 5 all the way to the right. And if I run the exact same line of code again, it has now pushed the 4 all the way to the right, okay? And so I can just kind of repeat this over and over again, right? I can perform multiple sweeps, and I can do a total of 4 sweeps. And I can just say, okay, for S, so I just have the for loop, so it's, double nested for loop, not great for efficiency, but it will get the job done. And so all I've done is just taken that line of code that we've written earlier, and then I'm just putting that inside another for loop, and we're gonna run it S times, which is for basically the length of the X, okay? If we have a total of 5 things, we need to run 4 sweeps on it. And this will work, okay? But one thing is that this, when I run it the second time, it's running through the entire length of the vector, and we actually don't need to, right? And the last thing, we're still comparing 4 and 5, and we don't actually need to do that. We could lock in position 5, we can lock in position 4. The next time we run it, we can lock in position 3. So the first time, we move through the entire vector, which is the length of x minus 1. The next time we run it, we run through the length of x, the vector x, but we can subtract 2. And then the third time we run it, we can subtract off 3, so on and so forth. So we could just make it a tiny bit more efficient, okay, by shrinking how many kind of iterations we have to run through every time we kind of perform this, right? So here I'm going to start off with 0 values locked, okay? And then every time I do this, okay, we are going to increase the number of positions that get locked. So I have my inner loop, okay, which will swap the values. And then after the inner loop runs all the way through, I could lock in one more position, okay? So the inner loop only has to do length of x minus 1, and then minus how many positions get locked. And so we start off with 0 locked positions, and the next time we run it, the number of locked values is going to increase, and the number of locked values are going to increase, right? So all I did was I just added a variable at the top outside of the loop, and then I update it inside the outer loop after the inner loop completes, right? And you can kind of review this. And again, we're still working in the global environment, so if anything goes wrong, I can kind of check, like, okay, did something go wrong? How many values got locked? So on and so forth. I tested out 5, 4, 3, 2, 1. It looks like it sorts it 1, 2, 3, 4, 5. Okay, so basically just a couple other notes here, and I can say, all right, what about 40 values randomly sampled? Is this going to work? And I run it, and it looks like it sorts it 1 through 40 in correct order, right? So I always kind of test it out some more. And so now that this looks like it's working, all I'm going to do is I'm going to take the code that works, and I'm going to just wrap it inside a function. So now, after I get everything working in the global environment, I just take this exact code from locked down to returning X, and I wrap it inside a function, okay, in bubble sort, and then I try running it, and I wrote nothing happened here, okay? And the reason why was because I forgot to, in this thing, I didn't include return X, so I just have to include return X at the very end, all right? So return X at the very end, and so now it works, right? And so here's sample 100, and after running bubble sort on that, it sorts it, and we can kind of try it out again, right? So a little bit of just strategies there. Again, break your task down into smaller steps, and don't start building a function right away. Kind of work in the global environment and get a chunk of code working, right? And anytime you get some kind of code working, try it out with different examples. Don't get satisfied and just say, okay, work for this, my one test case, right? Try different test cases. See if you can kind of break your little piece of code. And if you can't break it, then move on to the next thing, right? And just make sure everything's kind of working, okay? And add to your code incrementally and test each change thoroughly before moving on. A lot of times you can work inside a script file, and if you put remove list equals ls inside your at the top of your script file, then it's always going to delete everything in your global environment every time you load up your script. So that's one thing that can kind of speed things up. Now you probably want to remove that at the very end, but as you're kind of developing it, that's a helpful thing to always kind of clear out your global environment. And I can't stress that enough. Sometimes students come to me during office hours and I see their global environment has like 100 objects from like 3 quarters ago, okay? And I'm just like, what's going on? But it's always helpful to kind of clear that out, right? So so put that in there. All right, let me just talk a tiny bit about homework 2. And I know some of you haven't even opened up homework 2, okay? But one of the things you have to do is you have to draw the game board, which is just a rectangle, okay? It's just draw a rectangle with a bunch of grid lines, okay? But when you first see it, you're like, it might feel overwhelming, okay? And so here is just some ideas and tips on getting started, all right? So one thing you can do is you can just create a blank plot, doing plot new, okay? And then one of the powerhouses that you're going to be using is this, if you're using base R, is you're going to use this function called segments, okay? And with segments, you're going to put in the x and y coordinate of one end and the x and y coordinate of the other end. So if I put in 0, 0 and 10, 10, it's going to draw a diagonal line from 0, 0 to 10, 10, okay? And that's what we have here. And to draw the game board, what do you want to do? You want to draw horizontal lines this way, and then horizontal or vertical lines this way, right? So here's the first one, and it's helpful to have a little sheet of graph paper, or just a sheet of graph paper, and you say, okay, what are the coordinates here? Okay, this is going to be 0, 0, and what is this coordinate over here? 10, 0, okay? And then, what about this one? This one is 0, 1, and this one is 10, 1, right? And we don't see the axes, so we can't really see that. And if we wanted to do 3 lines, now we're running into problems because I did 0, 0, 10, 0, 0, 1, 10, 1, and 0, 2, and 10, 2, and we're like, okay, where did that 10, 2 go? Okay, and so one issue there is that R doesn't really know what axes to set, and so it says, okay, well 0, 0 goes down here. Okay, the next one is 0, 1, so it goes up here, and then it draws the window there, and then it goes, okay, 0, 2, and it starts up here. Now it's outside of the range, right? So one thing we can do is we could use plot window, right? Now we can put in some kind of like where the corners should be, right? So the x limits will be 0, 10, the y limits are going to be 0, 10. Aspect ratio equals 1 means the x scale is going to be equal to the y scale, and so this will make circles look like circles and stuff like that. And so now I can start kind of building up, and now I've got 3 lines, and now I can have a for loop, okay? And I'm going to put in, instead of, 0, 0, 10, 0, 0, 1, 10, 1, 0, 2, 10, 2, we can say, okay, well, I just need to go up to R, right? R going from 0 to 10, and I can draw vertical lines that way, okay? And then doing the same thing, vertical segments, and then now horizontal segments. Now I can get a grid like this, right? And so just think of this and build incrementally and think about what kind of lines you need to write for each thing there. Okay, so that's just some tips on getting started with homework 2. As you try to think about these things, and again, only wrap things in the function at the very end after you get everything working, okay? And that's a big tip there. Okay, have a great weekend. We will see you on Monday, and good luck as you start looking at homework 2.